Propulsion systems used in modern naval vessels. Propulsion systems selection is an important part of naval ship design. These systems have always had to satisfy speed and ship service power requirements. Nowadays, increasing fuel costs are moving such decisions towards more fuel-efficient solutions. Unlike commercial ships, naval ships operate in a variety of speeds and electric loads, making fuel consumption optimization challenging. Propulsion system choices for modern naval vessels depends on some criteria. Traditional criteria: ship speed requirements, shock capability, noise reduction, infrared signature. Additional criteria: change in operation requirements, greater range of speed, added mission flexibility, longer periods away from base with smaller crews, and cleaner emissions. An emerging global macro trend in naval engineering over the last 15 years has been a decisive migration to more electric propulsion due to progressively increasing electrical load demand and a focus on affordability. All-electric and hybrid electromechanical arrangements are routinely demonstrating merit since 1990 in the Royal Navy Type 23 anti-submarine warfare frigate and subsequent modern frigate programs. These include the Royal Navy Type 26, German Navy F-125, Spanish Navy F-110, Italian and French Navy's FREMM, Republic of Korea Navy FFX-2 frigate and Finnish Navy SQ-2020 frigate programs. Types of propulsion systems: combined diesel or gas. Combined diesel or gas is a type of propulsion system for ships that need a maximum speed that considerably faster than their cruise speed, particularly warships like modern frigates or corvettes. For every propeller shaft there is one diesel engine for cruising speed and one geared gas turbine for high-speed dashes. Both are connected to the shaft with clutches. Only one system is driving the ship, in contrast to combined diesel and gas systems that can use the combined power output of both. The advantage of combined diesel or gas is a similar gearing compared to combined diesel and gas, but it needs either more powerful or additional gas turbines to achieve the same maximum power output. The disadvantage of combined diesel or gas is that the fuel consumption at high speed is poor compared to the combined diesel and gas. Combined diesel and gas. Combined diesel and gas is a type of propulsion system for ships that need a maximum speed that is considerably faster than their cruise speed, particularly warships like modern frigates or corvettes. Pioneered by Germany with the Köln-class frigate, a combined diesel and gas system consists of diesel engines for cruising and gas turbines that can be switched on for high-speed transits. In most cases, the difference of power output from diesel engines alone to diesel and turbine power combined is too large for controllable pitch propellers to limit the rotation so that the diesel cannot continue to operate without changing the gear ratios of their transmissions. Because of that, special multi-speed gearboxes are needed. This contrasts to combined diesel or gas systems, which couple the diesels with a simple fixed ratio gearbox to the shaft, but disengage the diesel engines when the turbine is powered up. For example, the new combined diesel and gas-propelled Fridtjof Nansen-class frigates of the Royal Norwegian Navy, the gear ratio for the diesel engine is changed from about 1 to 7.7 for diesel only to 1 to 5.31 in diesel and turbine mode. Some ships even have 3 different gear ratios for diesel engines, one each for single diesel and double diesel cruises, and the third when the gas turbine is engaged. Such a propulsion system has a smaller footprint than a diesel-only power plant with the same maximal power output. Since smaller engines can be used and the gas turbine and gearbox don't need that much additional space. Still, it retains the high fuel efficiency of diesel engines when cruising, allowing greater range and lower fuel costs than with gas turbines alone. On the other hand, a more complex, heavy, and troublesome gearing is needed. Typical cruising speed of combined diesel and gas warships on diesel power is 20 knots, and typical maximum speed with switched-on turbine is 30 knots. Combined diesel, electric, and diesel. Combined diesel, electric, and diesel is a naval propulsion system in which an electric motor and a diesel engine act on a single propeller. Transmission system takes care of making one or both motors act on the propeller shaft. The combined diesel, electric, and diesel propulsion system is based on the use of electric motors directly connected to the axis, generally two, of the propellers. The electric motors are powered by diesel generators and to have higher speeds, as happens in Codat propulsion systems. The higher power diesel engine is inserted, which is disconnected from the transmission system to return to cruising speed. This system that uses diesel engines for both propulsion and for the production of electricity for onboard services significantly reduces costs, as the number of diesel engines for the various ship services decreases and the electric motors need less maintenance. Furthermore, since electric motors can work more effectively in a larger number of revolutions and being directly connected to the propeller axis, the transmission systems for coupling and decoupling the diesel-electric systems with the diesel engines used to have higher speeds. The combined diesel-electric and diesel system has been adapted in the new Vulcano-class logistics support ship under construction for the Italian Navy. Combined diesel-electric and gas. Combined diesel-electric and gas is a modification of the combined diesel and gas propulsion system for ships. A variant called the combined diesel-electric or gas system contains the same basic elements but will not allow simultaneous use of the alternative drive sources. A combined diesel-electric and gas system employs electric motors which are connected to the propeller shafts. The motors are powered by diesel generators. For higher speeds, a gas turbine powers the shafts via a cross-connecting gearbox. For cruise speed, the drivetrain of the turbine is disengaged with clutches. This arrangement combines the diesel engines used for propulsion and for electric power generation, greatly reducing service costs, since it reduces the number of different diesel engines and electric motors, requiring considerably less maintenance. Also, electric motors work efficiently over a wide range of revolutions and can be connected directly to the propeller shaft, so that simpler gearboxes can be used to combine the mechanical output of turbine and diesel electrical systems. Another advantage of the diesel-electric transmission is that without the need of a mechanical connection, the diesel generators can be decoupled acoustically from the hull of the ship, making it less noisy. This has been used extensively by military submarines, but surface naval vessels like anti-submarine vessels will benefit as well. Combined diesel and diesel. Combined diesel and diesel is a propulsion system for ships using two diesel engines to power a single propeller shaft. A gearbox and clutches enable either of the engines or both of them together to drive the shaft. Two advantages over simply using a single, larger diesel engine of the same total power output are that 1. Diesel engines have somewhat better specific fuel consumption at 75% to 85% maximum output than they do at only 50% output. 2. There is a weight and size advantage to using two higher speed engines compared to a single lower speed engine, even with the slightly larger gearbox system. Combined gas or gas. Combined gas or gas is a propulsion system for ships using gas turbine engines. A high-efficiency, low-output turbine is used for cruising speeds, with a high-output turbine being used for high-speed operations. A clutch allows either turbine to be selected, but there is no gearbox to allow the operation of both turbines at once. This has the advantage of not requiring heavy, expensive, and potentially unreliable gearboxes. The reason that a smaller turbine is used for cruising is that a small turbine running at 100% power is more fuel efficient than a bigger turbine running at 50% power. The system is currently used in the 3 ships of the Russian Navy's Slava-class cruisers, the Japanese Maritime Self-Defense Forces, Hatsuyuki-class destroyers, and the Dutch Navy Kortenaya-class frigates. Combined gas and gas. Combined gas turbine and gas turbine is a type of propulsion system for ships using 2 gas turbines connected to a single propeller shaft. A gearbox and clutches allow either of the turbines to drive the shaft or both of them combined. Using 1 or 2 gas turbines has the advantage of having 2 different power settings. Since the fuel efficiency of a gas turbine is best near its maximum power level, a small gas turbine running at its full power is more efficient compared to a twice as powerful turbine running at half power, allowing more economical transit at cruise speeds. Compared to combined diesel and gas or combined diesel or gas, Codex systems have a smaller footprint but a much lower fuel efficiency at cruise speed, and for combined diesel and gas systems, it is also somewhat lower for higher speed dashes. Combined nuclear and steam propulsion. Combined nuclear and steam propulsion system is used on the Kirov-class guided missile cruisers. Complementary to the nuclear component, there are 2 conventional boilers installed as backup in case of reactor failure. Both components can drive 2-gear steam turbines generating 120,000 horsepower at 2 prop shafts. Integrated electric propulsion. Integrated electric propulsion or full electric propulsion or integrated full electric propulsion is an arrangement of marine propulsion systems such that gas turbines or diesel generators or both generate 3-phase electricity, which is then used to power electric motors, turning either propellers or water jet impellers. It is a modification of the combined diesel, electric, and gas propulsion system for ships, which eliminates the need for clutches and reduces or eliminates the need for gearboxes by using electrical transmission rather than the mechanical transmission of energy. So it is a serious hybrid electric propulsion instead of parallel.